I love algebra. I do. Because it's what we're doing in algebra is we're finding truthiness. Okay? We're finding the truth to make an equation that I can see, to make that be real, to make that be true. Okay? That's what we're doing. Okay? Now, in order to do that, we got to follow certain rules, which that's fine. We can follow the rules of math. Okay? We like math. Math is the coolest. Okay? That's why I teach it. It's so cool. So the first rule of the math is the golden rule of algebra. The golden rule of algebra says that in an equation, because we talked about equations and expressions yesterday, right? The difference between them, and the equation's got an equal sign. Okay? So in an equation, the golden rule of algebra says that what we do on one side of the equal sign, we've got to do on the other side. We have to do that exact same thing. So if I'm adding 3 to the left side of an equation, I've got to add 3 to the right side of the equation. Now, back when you were in middle school in your pre-algebra 1 days, I think if you went to John here, I think it was a class called pre-algebra. Okay? Your teacher probably represented an equation as a balance, and that you always want to keep them balanced. So if you add 3 to one side of a balance, it's going to get out of whack. So you got to add 3 to the other side. And that's what we're talking about. That's a great visual representation of the golden rule of algebra. Multiplication, same thing. Division, same thing. Subtraction, same thing. Powers, that rule applies to powers. That rule applies to radicals. Take roots at some point in time. All that stuff applies to this class. Yeah? Rule number 2, or reminder number 2, if we're going to move something to the opposite side, we've got to do the opposite. And we're going to use inverse operation. So if we want to move an addition, we got to subtract. If we want to move a multiplication, we got to divide, and vice versa. Okay? If I want to get rid of a power, I got to take a root. If I want to get rid of a root, I got to take a power. Third reminder, your answer is always in the form variable equals number or number equals variable. Okay? Now, this does not mean that. Okay? That be bad. Okay? Because we just want the singleton variable equal to a number. Okay? So we just want x or whatever variable it is that we're choosing to solve for. One of the 25. Just so you know, there's only 25 variables to choose. Because we don't like I, because that means imaginary. Just, okay? And we'll get to those later on too. Okay? And lastly, reminder number 4, it never hurts to check your answer. Because you might have missed something along the way, and then that's going to screw up your answer. And you should be able to say at the end of an algebraic problem, yep, I'm 100% confident in that answer. I know that I'm right. All right. Let's solve some equations. Really what we're going to do today, we're just going to solve equations. We're going to solve different kinds of equations. And we're going to solve and solve and solve and solve until we can't solve anymore. Okay. In example A, what would you do first? Subtract 9 from both sides? I would agree. That's one thing. Is that the only thing that you can do first? Would that be smart, though? I mean, you could, but then you'd be introducing fractions into it. You know what I mean? You'd have negative 9/4 then plus that. You could, but we'd have fractions. Damn, I'm not sorry to shoot down your idea. Yeah. Could we add 4x to both sides? What I'm getting at is there's more than one way to solve this equation. Just like there's more than one way to get from Wausau West High School to Moseley, the town of Moseley. You could jump on the highway. You can get there pretty quickly. You could get on the highway but get off at N and then take KK past the school forest and all that stuff. Go out to Marathon City, cut down on 107. It all depends on what you want to do. And as long as you're still getting to your destination, all is good. So Raya, you said subtract 9, correct? Okay, I like that. And then that leaves me with negative 4x equals, let me go with negative 32. Then what? Divide by negative 4 now? No. That's a bad negative 4. And then that's going to give me x is equal to 8. And then we check our equation. So we got 9. 4 times 8 is 32. 9 minus 32 is negative 23. It checks out on both sides. Bada bing, bada boom. Done. In example B, you've got a decision to make right off the start. And that decision that you've got to make right off the start is, do I want my variables to be on the left side, or do I want my variables to be on the right side? And the reminder that I gave you earlier said, it doesn't matter which side they're on. You should get the same answer. So go for it. Try solving me example B.
Really?
Yeah, I'm recording right now. Because then I put it on the note. I'll show you that at the end of class. Okay. So I'm going to add x to both sides. And at the same time, I'm going to add 3 to both sides. So then that gives me 8x on the left, and that gives me 18 on the right. Then I'm going to divide both sides by 8. Now, unfortunately, 18 does not evenly divide by 8. However, the fraction 18/8 can be reduced to 9/4. Oops, that looks too much like 9/4 negative. Okay? And just so you know, because we are a college level algebra class, we are going to want to leave our answers in improper fraction form because they are the neatest of the neat. Okay? No rounding involved, no extra stuff involved. It's just 9/4 is it. Okay? And you don't have to ask me, what decimal place do you want it rounded to? None. I want it in fraction form. Okay? So fractions whenever possible. Good? Now, had you wrote there 2.25, Okay? That's okay, but you didn't know at the time. Now you know, and knowing is half of that. G.I. Joe taught me. Try these. Try all three of them. Okay, so on this first one, I would start off by, I would subtract 9. That gives me negative 4/5 x equals negative 41. Agree so far. Okay. Now here is, you got a little bit of a, two paths diverge in the woods kind of deal. You can go down either one. Doesn't really matter. Option number one is you could multiply both sides by 5, and that would get rid of the fraction. Then in your next step, you would divide both sides by negative 4. Okay? And you'd get an answer that way. The other option is you could multiply both sides by negative 5/4, because you're just basically combining those two steps into one. The 5 on the top is the multiplying by 5 to get rid of the fraction. The negative 4 on the bottom is the dividing by 4 to get the next step in that process. Okay? So then on this particular one, on the left side, you would just get x. And on the right side, you'd get 205/4. Okay. 205/4 multiplied by negative 4/5 would be 41. Yeah, negative 41. So 9 minus 41 gives me negative 32. Yep, checks out. Boom. Oh, enough. I don't know why my finger must have got too close. Double tap that one. All right. So we got that. Okay. In letter D here, now what you first have to do is you first have to, because you've got two x's on one side, so you first got to combine them. Both are in fractional form, so we have to have what's called a common denominator in order to combine them. And that common denominator is 15. So to go from 3 to 15, I multiplied by 5, so that one's going to be 10. 2 times 5 is 10. To go from 5 to 15, I multiplied by 3. 3 times 3 is 9, so that one's 9. So this simplifies to be 1/15 x equals 4. You look like you were confused by that.
Yeah, no, I have that answer,
Okay.
but I didn't make common denominator.
Okay. Did you multiply everything by 15? Yeah, that's fine too. That's another way to do it. Yep. Multiply everything by the common denominator and get rid of the fraction. Same thing. Yep. Yeah. You just I just did that in the reverse order. Because there's my multiplying by 15, which you did first, and you should get x is 60. 60 divided by 3 is 20, times 2 is 40, 60 divided by 5 is 12, times 3 is 36, 40 minus 36 is 4. Good thing. Okay. This one, same, it's just got decimals. That's the only difference. Okay. So we do it the exact same way. So really that's 24 divided by 6. So then G here is 4. Yes?
I have a question about C.
Talk to me.
When I put that in my calculator, I got 51 and 1/4. Is
Yep.
that fine?
Nope.
No?
Nope.
Okay.
So on your calculator,
Yeah.
hit the. You using a blue one?
Yeah.
Okay, good. So it's the second of the fraction key. So from 51 and 1/4,
Mm-hmm.
it's second, and then the fraction key again. And it should give you 205 over 4.
Okay.
You might have to hit enter too. Okay? Two special solution type cases. Okay? So if we go about solving this first one, I would first off distribute the 5 into there. That would give me 5x minus 20. Anybody see an issue? What's your issue? If we move the 5x to the other side, what happens to it? Goes to 0, right? Okay. So if I subtract 5x here now, without doing anything else, I mean, I could add 20 to both sides if I wanted to. I've got negative 20 equals 12. And that is a false statement, right? Because that's not true. So in this particular case, when we have a false statement, the answer then is no solution. There is no value of x that would make that equation be true. None. The other special situation, which I'm sure you probably have already guessed at right by now, going to distribute again 10 minus 5x. And I'm going to combine like terms over on this side. These two can combine to be 10, and these two can combine to be minus 5x. When I go to add the 5x to both sides, I get 10 equals 10, or I get 0 equals 0 if I subtracted 10 at the same time. That now is a true statement. So this one is infinite. Solution. So it doesn't matter what you choose for x in this case, it will work. Right? All of the numbers work in this particular way. Okay? So you've got no solutions and you've got infinite. I think we've got, oh yeah, we've got word problems. I love me some word problems. So with word problems, comes a couple of steps. I like to follow some steps when we're doing it. First step in a word problem is the step that people always forget. You got to read it. Okay? You got to read it, and you got to read it carefully too, because you got to read it in order to understand it, and read it in order to figure out, decipher the information from it. So John rents a sailboat on vacation. He's on vacay. He's down somewhere. He's renting a sailboat. The boat has a rental fee of $45. So even just to look at the boat is $45. Okay? Plus a $7 per hour fee. If John is charged 101 total dollars, how many hours does he rent the sailboat for? So his final bill is $101. Okay? So we've read the problem. The next thing that we should do, because we're in the maths class, is we should come up with some kind of an equation with variables. Okay? And we should define what those variables are. So what are we looking for? Number of hours that he rented the boat, right? So that's going to be our variable. Favorite letter? X. Okay, that's fine. I'm okay with X. So X is going to be the number of hours that we rent. Okay. Now we should come up with an equation. What kind of an equation can we come up with? What has a rental fee of $45? I'm just rereading the problem. What has a rental fee of $45? Probably going to need to use 45 somewhere in it, right? What do you got?
So it's 7x plus 45 equals 4.
I love it. I would write it as 45 only because I was reading the thing. So boat has a rental fee of $45 plus a $7 per hour, and we said the number of hours was X, and that's going to be $101. Or 7x plus 45 equals 101. Okay. We're good there. Now we can solve that. Subtract 45. What's that? 56. Divide by 7. Gives me 8.
Oh, yeah.
Yeah. Okay. Now, the kicker in a word problem is the last one. What? The kicker in the word problem is the last one. The last little thing we got to do.
Label it. Correctly.
Yep. Does it make sense? And does it have a label? Okay. So in this case, does it make sense that he rented the boat for 8 hours? Yeah, that makes sense. Makes a lot of sense. Okay. So let's tell. What if we would have gotten an answer here of -8? Okay. That should be a flag should be going off, an alarm bell should be going off, and all that stuff. That wait a second, can't rent it for a -8 hour time frame. Okay. So that's what I mean by does it make sense. And then the label is, since we said X was the number of hours, we're going to say that he rented the boat for 8 hours. Okay? Try that. A salesperson at an electronics store has a base salary of $10,000 per year and earns a 15% commission on total sales, how much must the salesperson sell in order to earn $25,000 in 1 year? So I would say we still going with X. Yeah, I'm fine with X. Is sales. How much he's got to sell. Right? And that's going to be in monies, right? Dollar bills, y'all. Yeah? So he got a base salary of $10,000. So we're starting out with $10,000. Right? And then to that, he gets commissions. So 15%, and got to convert that to a decimal. 15% in the decimal. 0.15. Okay, so that's 0.15 of X. And he wants to know, or they want to know, how much to get 25,000. Okay. Subtract 10,000. That gives me 0.15 X. 15,000. 0.15. That should give me X equal should be 100,000, right? Move over to. So this person would have to sell $100,000 worth of electronics on top of their base salary. Okay? Questions, comments, concerns, clarifications on solving?
So we wouldn't like change it to 1.15?
1.15?
Yeah.
That would be if he I'm trying to, that's if he adds 15% to it. You know what I mean?
Yeah.
So yeah, so it's 15% of it, so it's just 0.15. Okay? So, did I put, oh, I did not. Okay, so tomorrow is the 9th. 9 tomorrow. Week 1 worksheet is due. And you have formative 1-1 tomorrow. Okay? So you got those two things due. So the yellow worksheet that you have is due tomorrow, and you can have the remainder of the time to work on it. And then you've got a formative tomorrow. Okay?